Hello, everybody. Welcome to our live YouTube program on space volcanoes. We're very excited that you're here in the live YouTube spaceship, as we call it. My name is Jackie Faraday. I'm an astrophysicist at the American Museum of Natural History, and I'm going to be your host today. I have a couple of housekeeping announcements before we actually get started with the program. So I'm looking at the chat right now, and I can see that you guys are already in here. We're going to be using the chat throughout this program to find your questions, bring them live to the presenters so that we can get you as much involved in the content as we can. So why don't we practice a little bit? Can you tell us where are you watching from? I can see already, Emmett, you're from PS62. I've seen people writing that they're from lots of New Yorkers here, from Queens, from Brooklyn. So we're excited to see where you guys are coming from, and make sure you utilize this chat throughout to ask whatever questions you have about space volcanoes. And important to that is that not only will we be monitoring the chat and bringing them into the live YouTube conversation, but you have several, two fierce female scientists in here that are going to be taking your questions as well and answering them as you go along. So you have our very own Ro Kinsler, who's in the chat, and you'll see her there, as well as Dr. Jasmine Bayron, who will also be answering your questions. So there, and I'll be grabbing them. More than that, we're about to get started with, but I want to announce that the museum is open. If you guys have been considering taking a trip, we are open. You just have to get your tickets ahead of time. And important too is that on June 12th, we will be reopening a newly renovated Hall of Gems and Minerals, which we're very excited about. So put that on your calendar of things to do this summer. And the Hayden Planetarium is also open. We've been doing these live programs on here for some time, but the Hayden Planetarium is also open. And you can now come and watch our brand new space show, Worlds Beyond Earth. And our next astronomy program announcement on this is that on June 4th at 1 p.m., we'll be back here with another one of our live programs here. It's going to be about the upcoming partial solar eclipse, which is going to happen on June 10th, but we're going to do the live program on June 4th explaining all about that. So stay tuned. There'll be more on that. So without further ado, let me bring in our two presenters. We have Denton Ebel, who is one of the curators in the Earth and Planetary Sciences Division at AMH, as well as Denton.
Hello. Good to be here.
And then we've got Marina Gemma. We'll bring Marina in here too. Hi, Marina.
Hi, everybody.
And so we're very excited about today's tour of space volcanoes that you guys are going to take us on. And Marina, you will be piloting and presenting and piloting our OpenSpace program, which you could probably give us the little link to here and then get us started.
Yeah, absolutely. So today we're using OpenSpace, which is a free data visualization software that takes real data from places like NASA and visualizes it so we can explore not only our solar system, but the entire universe. So if we can bring up OpenSpace now, let's get started. So you can see where some are familiar. This is AMNH, the home institution of Jackie, Denton, and I. And we're starting our journey here, but we're going to travel to some hot spots and maybe even some cold spots to explore the subjects of today's program, volcanoes. So one of the best ways to learn about what's on the inside of worlds is to look at what comes out of them. So volcanoes are ways we can get underneath the surface of not only Earth, but of alien worlds as well, to learn about what these worlds are made of. So I'm going to zoom out to this global view of Earth. And what I'm going to do now is actually turn off the cloud layer so that we can better see the volcanoes on the surface of the Earth. But we're not only going to explore volcanoes on Earth's surface today. We're going to investigate volcanoes across the solar system and how they shape those worlds.
We're going to explore different types of volcanoes, hot ones and cold ones. We're going to explore effusive or oozing volcanoes and explosive volcanoes that send rocks and gas up into atmospheres or off of planets. Explosive volcanoes act like opening a shaken soda bottle because their magma, the molten rock, is full of gases, and it makes bubbles which are explosive. Effusive volcanoes, effusive. What is that? It's like toothpaste, like boiling milk spilling over the side of a pot. These magmas, these lavas, have fewer gases in them. And so they sort of ooze out like toothpaste out of a tube if you squeeze it. So we have effusive and explosive volcanoes, two different kinds. We're also going to talk about time, active versus sleeping or dormant, like dormir, or extinct volcanoes. An active volcano currently erupting or erupted recently or might erupt very soon. And that's volcano prediction is very important for human safety. Dormant or sleeping volcanoes have been quiet for a long time, but they might erupt again very soon. And extinct volcanoes are those that haven't erupted in over 10,000 years. And extinct volcanoes are very interesting for lots of reasons because they tell us about the history of planets, of the Earth itself, and how things have happened in the past. And so we understand how things on Earth work by understanding volcanoes. And we also understand by looking at the Earth, which we know best of all planets, how things happen on other worlds. And we understand that many of the processes we see on the Earth are universal. But we have samples of the Earth that we can look at, and we can put in museums and look at forever. And we also see new volcanoes erupting and things happening in real time. And these rocks record the Earth's history. On other planets, we can see from satellites, and on Mars, we have robot geologists that can analyze rock chemistry of the volcanoes that shaped the surface of Mars and its atmosphere. Marina, where on earth have you taken us here?
So I've flown us to St. Vincent, and on the right, you can see a volcano called La Soufriere. And we're talking about this volcano today because it's been in the news due to its recent eruption, which is still ongoing. So St. Vincent is located in the Caribbean, which has many islands made by volcanoes and shaped by erosion. So those valleys that you see on the mountainside were made by water. So how do you get the material to make an island in the middle of the ocean? So this material actually comes from the inside of the Earth via volcanism. And volcanoes are so important because they bring stuff from the inside of worlds to the outside. And many of the islands across the world form this way. And though volcanoes can create new places to live, like the islands you're seeing here, they can also be very dangerous if you live too close.
So this is what a volcano looks like if you're up close, a little close here. This is the Soufriere volcano on St. Vincent that is explosive and hot and active. Here's it looks like from the ground, and here you see it from a distance. It last erupted just last month. What you're seeing here is a mixture of hot gas and rock dust, hot rock, all escaping from the Earth explosively and rising because it's hot, and also it's being pushed from below by more material coming out from the inside of the volcano. And these kinds of volcanoes provide a lot of gases into our atmosphere from within our planet Earth. And volcanoes have supplied gases to the atmospheres of other worlds as well that we'll visit later. So this is now what that same volcano looked like from space, from near-Earth space. And the plume looks kind of like a pancake. The brown part is where the dust and gas, hot material, is mixing with white clouds. And when this material is so hot and under pressure trying to get out, it hits the upper atmosphere, it spreads out because the air is much thinner. And we're looping this clip, of course, so you can see it more than once. But not all volcanoes send plumes high up in the atmosphere. Let's go to a different volcanic island.
So we're zooming out now from La Soufriere and St. Vincent, and we are going to travel to a volcano on the island of Iceland.
Oh, there's Greenland.
Greenland, yeah.
As you get us there, we've got questions coming in the chat. And just to remind people, tell us where you're also from when you bring up your question. But from Francis H., we've got a lot of questions about lava. And Francis H. is asking how hot the lava is inside a volcano. And can it be very different temperatures?
Well, yes. Depending on what the lava is made out of, it can be, lavas can be of different temperatures. But they're well, in centigrade, they're 800 to 1,000 degrees centigrade, can be even hotter. And these rocks are very, very hot, and the gases that come out as bubbles are roughly the same temperatures as the lavas themselves. So these are very hot gases as well that come out of these volcanoes. Some volcanoes, as we're about to see, don't have so much gas, and here we are at Iceland. You can see tons of lava flowing from the many volcanoes that made up the island of Iceland.
So we've arrived here at Iceland, and the volcanoes here are a little bit different from St. Vincent because they're effusive, meaning the volcanoes ooze lava that tends to stay on the surface. So the volcano that we're zooming in now on in Iceland has also been in the news quite a bit because it's currently erupting. And lava flows from Iceland's many volcanoes shaped the island itself, creating all these peninsulas that you see around the island. And if you caught it earlier, those big white caps were actually glaciers. So we're going to show you now some amazing clips from this active volcano right here on this peninsula in Iceland.
So this is effusive volcanism, and what you're seeing is called a caldera. This is the source of the lava that's flowing in these tons of red material that's red because it's so hot. You couldn't reach these temperatures in your oven in your home, for example. If you put a piece of rock in your oven, it does not melt. So these are very, very hot, and the hot rock is bubbling like a cauldron, and that's what the root of the word caldera is. And these rocks in Iceland, called basalts, don't trap so much gas. You can see some gases coming off, but they're not explosive. The gases that were in these rocks have left them already. They don't trap as much gas, and so they don't make huge plumes like we saw at St. Vincent. Instead, they make smooth lava flows like rivers of melted rock. So we see that already different types of rocks form different kinds of volcanoes. Some are gas-rich and some are not gas-rich. People can live nearby these volcanoes more safely because they're not so explosive. Another place on Earth like this is the island of Hawaii. Some of you may have been there. Let's go there now in our virtual spaceship called OpenSpace.
And as we go, Denton, we have another question more on the lava. We've got a lot of fascination with the lava. And this one comes from Lee Magadini, and he wants more details on what the primary element is in lava.
Well, the Earth is made of lots of elements. All the elements in the periodic table can be found in the Earth, except the very, very radioactive ones that are extinct. But in the Earth, the primary elements are, of course, silicon, magnesium, and iron. And the silicon, magnesium, and some of the iron combine with oxygen. So oxygen is actually the most abundant element in the Earth, and it's the most abundant element in these rocks. These rocks in these volcanoes are very magnesium rich. So magnesium silicates are the dominant minerals in these rocks. They also contain some aluminum and calcium as other important elements, and also iron. So those are the major elements in these lavas.
So we're here at the Hawaiian Islands, some of the best known volcanoes on Earth. And these islands are actually a chain of volcanoes that were created over time. And the big island of Hawaii, which we're focused on here, is the youngest and most active. So the active volcano on the big island is called Kilauea, and it's in the lower part of your screen. You can see the flows are going into the ocean. And it's in the heart of Volcanoes National Park. So if you ever visit Hawaii, you can actually drive right by Kilauea. And that's because Kilauea is an effusive volcano, meaning its lava oozes and isn't explosive. So it will likely continue to grow in size, perhaps even growing as large as the two other major volcanoes on this island, Mauna Loa here and Mauna Kea here. And we can see the many lava flows that have oozed out of Mauna Loa over time. Mauna Loa is the most massive volcano in Hawaii, meaning it covers the most area, but Mauna Kea is taller. In fact, it's the tallest mountain on Earth when you measure it from its base on the ocean floor. And because it is so tall, some of the world's best telescopes have been built at the top of Mauna Kea. Since the summit of Mauna Kea is so high up, there's less atmosphere for the telescopes to look through, meaning you can get much better astronomical data. And these volcanoes produce lavas whose chemistry changes over time. And the museum preserves in our collection a unique 6-kilometer drill core through a long history of lava eruptions on the island of Hawaii, which scientists sample to understand how the Hawaiian volcanoes have evolved.
Marina,
One of the reasons we went to Hawaii is because we have some samples we want to show you from the collections in the American Museum of Natural History. I'm going to start with this sample. This is a sample of a kind of lava called pahoehoe, P-A-H-O-E-H-O-E. And this is very ropey lava. It's like you squeezed toothpaste all out of a crack in the rock below, and it's solidified in these piles of material, and you can see it's a complicated texture. This is a kind of lava that's found on volcanic islands like Hawaii, also in Iceland, made by a basalt. And this is mostly glass. So this is rock that was molten and froze into a glass. It's not, you can't see through it like window glass. It's got a lot of iron in it. This is another rock. This is much lighter, it's less dense. This is called a'a. Ah is what you say if you step on this with bare feet. If you go to these places, you should wear strong boots, because this rock, again, is mostly glass and air. You can see right through it right here. And these little bubbly features are the way that this rock solidified. It's very gas rich. And again, you want to be careful handling it. That's why I'm wearing gloves. Another sample we have, this is from a more explosive volcano. This is called a bread crust bomb. Does anyone know why we call it a bread crust? This is because the crust, this part, when it cooled, perhaps even in the air, it cracked because it cooled and got a little bit, the rock volume gets smaller as it cools, just like the crust of a loaf of bread. Can you imagine this rock, very, very hot, like bread just out of the oven, only about twice as hot maybe, landing in your backyard? That's what happens sometimes in places which have explosive volcanism. So this is a bomb. These are come out of volcanoes. Very dangerous. And finally, I want to show you something. This is a special treat. This is called Pele's hair. Can you see that? It's like hair. It's glinting in the light, and it's very fine fibers of lava that's been made into these fibers by the processes of eruption. Pele is the Hawaiian goddess of volcanoes and fire, and is revered as the creator of the Hawaiian Islands. So many kinds of lavas can be formed by volcanoes, and the Earth has a lot of active volcanoes and also dormant and extinct volcanoes. Let's go back to OpenSpace and see where they might be on the Earth.
And
so now we're...
Just before we do that, Marina, because I want to
Okay.
make sure get this question, and Marina, this one can be for you too. RJ Centeno there's a lot of interest in the chat about how dangerous volcanoes are, and they want to know how fast volcanoes can erupt and how long they stay active for. This comes from an 8-year-old. How fast can volcanoes erupt? If you want to take that before you take us down.
I'll handle the question, and while Marina's driving, she's got a lot going on over there. So volcanoes, some volcanoes have been erupting quite often for a very long period of time. We think of Vesuvius in Italy, and Iceland is erupting quite often as well. Hawaii just went through a long period of eruption a couple of years ago. It's not erupting that much right now. So some volcanoes are very active on a consistent basis. And this is important to understand what's erupting and when it's erupting, because of course, explosive volcanoes send rock dust up into the atmosphere. And if you're, say, in a jet plane trying to fly through that, that's not a good idea. So the timing of volcanoes is something that scientists are working very hard to understand, because we want to be able to predict when eruptions are going to happen. And that's a very important cutting edge field of science. Some of you, our listeners, may actually become geologists and study that yourself. What we do know is that before volcanoes erupt, they tend to bulge as the magma and gases start to accumulate below them before they erupt. And we use seismology and we use the GPS positioning system to understand that process so we can predict volcanoes, eruptions, and save lives. Like we did with the Pinatubo, the Philippines volcano was predicted and people were able to leave the area before it erupted. Huge explosion eruption.
And just to give everybody if you're just joining us, we're about halfway through the program, and we are live on the AMNH YouTube channel with scientists Denton Ebel and Marina Gemma, and we are flying around the Earth. Marina, take it back away with OpenSpace.
Okay, so we're going to focus on the Pacific Ocean right now, and we're going to jump back to what Denton was saying about not only how many volcanoes Earth has, but also the distribution of volcanoes. So what we've added to OpenSpace to show you is basically a global plot of where volcanoes are on the Earth. So all of these triangles represent an individual volcano, and they're color-coded by how recently they've erupted. So the red triangles erupted in the last 200 years, the green triangles erupted in the last 1,000 years, and the blue triangles erupted over 1,000 years ago, or they're extinct. And so what we want to point out to you is that you can see a huge chain of volcanoes that travels up the west coast of North America, across the Aleutian Island arc up at the top there, off the coast of Alaska, and then down the eastern coast of Asia. These volcanoes are called the Ring of Fire, since they encircle almost the entire Pacific Ocean. And volcanoes form in those places specifically because that is where two tectonic plates, or even more than two tectonic plates, collide. And this is a common occurrence or a common area for volcanoes to form, where two tectonic plates collide or converge. But volcanoes can also form where two tectonic plates diverge or move apart.
So these volcanoes bring rocks from the inside of the Earth to the outside. They sample the Earth. They bring up samples of the deep Earth we couldn't reach by digging or by drilling. And we sample the deep Earth, the mantle of the Earth, at many different places this way. Rocks that come from deep below are brought to the surface by volcanoes, and that's how we know what our upper mantle, at least, the part we can't reach, is made out of. And in our museum, we have a large collection of what are called mantle xenoliths, and I have one here, like this one. And the inner part, green part, is from deep in the Earth. This is made of a mineral called olivine, magnesium silicate, that the mantle, upper mantle, is largely made out of. And this rock erupted as part of lava from an old extinct volcano in the American Southwest. And the outer part, this black rind, is the lava itself. So old volcanoes are really interesting places to visit, and we can go to national parks in the United States and do that. But before we actually go visit other planets and study their volcanoes, is there one more question from chat we can address before we go?
Yeah, we've had a lot of questions about, we're staying on volcanoes and lava, but Karen Teep Singe, let me put this chat for Soleil to make sure that your name gets on the big screen. I'm not sure if you're saying your name right. Are about underwater volcanoes. So do they erupt? Maybe how often they erupt? If you can address that.
We haven't even touched underwater volcanoes. It's a whole other story.
Yeah.
The oceans are some parts of the ocean. The Atlantic Ocean actually is spreading slightly, and there are is volcanic activity where the oceanic plates are spreading apart deep in the ocean. This is how we actually understood the concept of plate tectonics and how the Earth works. And so volcanoes like Hawaii and Iceland started under the ocean and grew and grew and grew until they became islands. So we showed the picture with the image with Mauna Kea, and the blue part was all below the ocean surface. So it's actually taller than Mount Everest, but most of it's hidden beneath the surface of the water.
And you know, Denton, one other question, since we were talking about Mauna Kea, from Forrest Madden, how can you ever be truly sure a volcano is extinct?
Well, we can date when the last eruption probably was, and that's a whole nother question. How do we date them? But the long and short of it is, some volcanoes, many volcanoes, we see the remnants, the leftovers. We can see where they erupted. We may even find the caldera from which that rock came, but it's very weathered, it's very old, and there's no heat coming from underneath any longer. There are places where we know there were giant volcanoes in the past, like in Yellowstone, for example. National Park is there, and there are geysers of water coming out from the rock. Is still very, very hot underneath. And one of our jobs as humans is to be aware of that and actually be able to predict, would it erupt again? All right, we're back in space.
Back in space, and we're actually a bit farther away from Earth than we were previously. I've zoomed us out to a bird's eye view of the solar system, and the different colored lines that you're seeing represent the orbits of our 8 planets. And what I'm going to do now is enlarge the size of the planets by over 1,000 times so you can see them from this distance.
Hey, I see Saturn. So this is the structure of the solar system. We have the inner planets very close to the sun relative to Saturn and Jupiter. And we can see the inner part. The inner part are rocky worlds like Earth, with rocky moons and rocky volcanoes. The outer part has the gas giants, particularly Jupiter and Saturn, with icy moons. But some of the moons of these large worlds are rocky worlds also, like the moon Io. And we're going to go there now.
Indeed. So I'll focus on Io. I'm going to make the planets small again so they don't overwhelm your view. And on Earth, we learned that there are many different types of volcanoes. There are volcanoes with different eruption styles. So you have explosive or effusive volcanoes, and also volcanoes with different levels of activity. So you can have an active volcano, a dormant volcano, or an extinct volcano. And what we know is that volcanoes aren't unique to Earth. So now that we're looking at Io, a moon of Jupiter, what do you think these pepperoni-looking spots are on its surface? Can anyone guess? If you guessed volcanoes, you are correct. So what do you think, before we even tell you anything about the volcanoes on Io, do you think these volcanoes are active, dormant, or extinct? Take a guess in the chat and let's see what you think. So multiple spacecraft have observed Io as they flew by, And they revealed that Io is a rocky moon that's home to hot, explosive, and active volcanoes. So if you guessed active, congratulations, you're correct. And the last observed eruption on Io was in fall 2019. But we can't continuously monitor volcanoes on Io like we can on Earth. So it could be erupting right this minute. Denton, what's this huge feature right in the middle?
Well, that is a volcano that's massive. It's named Pele, after the Hawaiian goddess of volcanoes we were talking about before. This volcano has been observed to show plumes reaching up to 300 kilometers or 190 miles. That's about the length of New Jersey. This was by the Voyager spacecraft in March of 1979. Jupiter's moon Io is the most volcanically active world in the solar system. Io erupts 100 times as much lava per year as the Earth does. And one of the things we're going to do is show you now the Discovery plume. This is the plume that confirmed active volcanism on Io. It was observed, not expected, but it was observed by the Voyager spacecraft in 1979 that confirmed active volcanism was happening right at that minute on the moon of Jupiter called Io. And here is a short series of images that were made much later in 2009 by the New Horizons spacecraft as it flew past Jupiter on its way to Pluto. And you can see this is an enormous, enormous plume. This is not Pele. This is another volcano called Svashtar. Now, this is a different view. This is a plume from the Voyager mission, again, showing an active plume. This is the Loki volcano. And Pele is seen below it, this big red ring with the dark center. The dark center is where the caldera is, and we were able to measure that composition and temperature of that caldera is 1,200 degrees centigrade. And all around you see this ring of red and yellow material. That is sulfur compounds that erupted and fell back onto Io as an icy frost. So Io is a world of fire and brimstone, which is sulfur. The surface is cold because it's so far from the sun. And the gases and sulfur form ices on the surface. So what I'd like to show now is a clip, a small segment from the Hayden Planetarium Space Show, Worlds Beyond Earth. And
before we actually do it, Denton, there's a question in here that I thought is perfect here from Lee Magadini, and that's on Io. Does it have an atmosphere? Does it not have an atmosphere? And does the plumes on Io, are they limited because it has no atmosphere so they can rise to great distances?
So we saw on Earth that the plume from St. Vincent was flattened out like a pancake when it hit the upper atmosphere, and it was mixed with clouds. Io does not have an atmosphere. It has atoms and molecules around it that we would call an exosphere, but it's essentially airless. So those plumes have nothing to stop them from going high into space before they fall back onto the surface of the moon. So here we are visualizing in the open space, or in the Worlds Beyond Earth. This is the space show, not in open space. And this visualizes the space show, what we've observed and what we've discovered at Io over the last 50 years. And we know these are really hot lavas that are glowing in the dark side of the moon because we went there with our spacecraft and we could actually tell their temperatures from a distance. This is a hot, rocky moon around a gas giant, Jupiter. We also see worlds of ice that have volcanoes. And Marina is now going to fly our OpenSpace virtual spacecraft to the planet Saturn.
So Enceladus is one of the larger moons of Saturn, but it's still smaller than our own moon. And we're visiting Enceladus because, as you might have guessed, it has volcanoes.
Saturn has a lot of moons, too.
It does. Do you guys think Enceladus has explosive volcanoes like St. Vincent on Earth, or effusive volcanoes like we saw in Hawaii? What do you think? Let us know in the chat and we'll see who's right. So while you guys think about that, we know a lot about Enceladus because the Cassini spacecraft orbited Saturn for 13 years and saw a great deal of this fascinating moon. Enceladus is icy with hardly any craters, and that's because it is active. These long cracks in the ice that you'll see across the surface of Enceladus were made by water as it froze. And the surface is slowly but surely changing over time and erasing any craters that form by impacts. So Enceladus is an icy, active, and explosive volcano. And you might be thinking, how can a volcano be made of ice? Aren't all volcanoes hot? Not all volcanoes are actually fiery fountains of lava. So Denton, can you explain how ice volcanoes work?
Yeah, so you see all these cracks, and in some places near the South Pole, we discovered with the Cassini spacecraft, by going there with these plumes of water ice, and this is an image taken of Enceladus from a distance, and you can see these plumes extend far out from this icy moon. And when the water escapes through the cracks, which is under pressure, the water freezes instantly to make tiny grains of ice. And these tiny grains of ice are reflecting the sunlight so that the Cassini spacecraft can image or take pictures of these plumes. And here's an image of these plumes taken up close. Most of the ice that's erupted actually falls back onto Enceladus, but Enceladus is small, and it's actually got a smaller gravity than our own moon partly because it's less dense. It's large. A lot of it's made of ice, and so its gravity is weak. So some of these plumes escape the orbit. It doesn't have an atmosphere. But Io is in orbit around Saturn, which is the second largest planet in the solar system. So these icy grains get trapped in Saturn's outermost ring. Some of them get trapped in the E ring of Saturn. Isn't that amazing? Volcanism on a moon is feeding ice particles to Saturn's rings. And Cassini went to Saturn for us so we could discover these secrets of Saturn. So this is the last of the active volcanoes that we know are active that we're going to look at today. But what about older volcanoes that are dormant or sleeping or extinct, not active anymore? And what can we learn from the dormant or extinct volcanoes in space? So Marina's going to pilot our virtual spacecraft to the red planet, Mars.
So yeah, we're focused back on the inner solar system, zooming in on Mars. And Mars is the most studied planet besides Earth. Humans have a lot of satellites around Mars from many different nations.
You can see 2 moons here.
Yeah, Phobos and Deimos. You can see it's 2 tiny moons. And what we're looking at is one of the highest resolution global maps that we have of Mars. And you'll notice as we zoom in that there's some strips that you can see. And that's actually missing data. So we don't have full coverage, but when we zoom in, the resolution is high enough that you could actually see a tiny Martian house. And what I'm doing now is I'm changing the time of day on Mars so that we can visit the volcano we want to see during the daytime. So we're coming around, and you can see that these big spots we're coming up on are volcanoes on the surface of Mars. So we also have rovers on the surface of Mars that are robot geologists that sample the rocks in place and tell us what they're made of.
And we have meteorites from Mars. And some of them are on display at the Museum of Natural History. And you can see them. We analyzed them very carefully, and we know they came from Mars, but we don't know where on Mars that these Martian meteorites actually came from.
So I'm zooming in now on Olympus Mons, the largest volcano in the solar system. You can see multiple calderas at its summit. And Denton, for those who might not know or might not remember from the beginning of the program, what's a caldera?
Well, you see these depressions. This is where bowl-shaped features, where the rock has collapsed when the molten rock under it has flowed out as lava. So it's kind of like an apple crust, pie crust, that collapses if someone takes out all the fruit from the inside without eating the crust. It collapses from the top down. And that's what you're seeing here, these calderas. And we see the same thing on Earth. Olympus Mons is huge. The area is about the same size as the state of Arizona, and the whole edifice here of these volcanoes is taller than Mount Everest. Its lavas were hot and effusive, and it's what we call a shield volcano, just like Mauna Kea in Hawaii. And here's a comparison image.
So Mount Everest, like Denton said before, is on a continent, which means that we can see all of it. But part of Mauna Kea is underwater, which is indicated in blue, and so we only see that top part colored in brown. But Olympus Mons is not only taller than both Mount Everest and Mauna Kea, it's actually taller than both of them combined. And as you can see from this diagram, it's also much, much wider.
So the biggest volcano in the solar system, volcanic complex, let's call it, is on Mars. That's really cool. But once an open question, is Olympus Mons active, dormant, or extinct? What do you think? It's a great question because we're not quite sure how long ago these volcanoes were active. But we can see from space that these lava flows have very, very few craters. There's a couple down at the lower left corner that you can see, but most of these lava flows don't have craters on them. So that tells us that it's a fairly young system. But we've not seen so far any volcanoes on Mars actively erupting, and we keep looking for that. So all the volcanoes on Mars probably are extinct and won't erupt in the future. Olympus Mons, then, is an extinct volcano, and it's effusive, like we saw at Iceland. And the estimates for its last eruption range from a few million years up to 25 million years ago. So as Marina was saying earlier, Mars is the most studied planet in our solar system, but we know much less about our other neighboring planet, which is Venus. And so now Marina is navigating the solar system to find Venus, which is about the same size as Earth. Mars is much smaller, which would explain why its volcanoes are so inactive today. So what are we seeing here, Marina?
So one of the reasons why we know less about Venus is because we're missing a lot of data. So what you'll notice as I pan around Venus here are these strips. And these are actually gaps in the data sets that we have from spacecraft that have been sent to Venus. And we visualize the surface of Venus from radar data or radio waves that are reflected from its surface. Some things down there look like volcanoes, like this image here.
This is an image made from the radar data.
Indeed. And so we know the surface isn't ancient because we don't see a lot of impact craters. So we think there's been volcanic activity sometime in the last billion years.
We don't know if these things that look like volcanoes are dormant or if they will erupt again in the future. We don't see a lot of impact craters, so we know that there has been activity. And really, we need to go there again to Venus and learn by going and discovering for ourselves what's going on with these features that look remarkably like volcanoes. What are they made out of, and how often they might erupt. And we're going to explore this question and many others about the Earth and Venus, Mercury, and Mars in our upcoming Frontiers presentation later this month. We'll be joined by Paul Byrne, an accomplished planetary scientist, who will explore some of these questions in a lot more detail, and especially the fascinating contrast between the Earth and our sister planet Venus. So we'd like to answer any further questions. I'm sure I see some in the chat over here. And
yeah, why don't we bring up this one last one? We have time for just this one last one, which I think is a good one on ending. It was from Caitlin Moriarty. Hopefully I'm saying your name right, Caitlin. How does a volcano become extinct? What's the process? And maybe you could speak to that from Earth, or maybe even for Mars or for Venus. It might be different.
Well, I'll talk about Mars for just a quick moment, and then I think Marina will talk about Earth. So on Mars, we think that the volcanism that didn't end it ended not so far back in time, is because Mars is much smaller than Earth, and it's cooled a lot more quickly than the Earth has cooled over time. It's also farther from the sun, doesn't get as much heat, but it's not the sun's heat that makes volcanism happen. It's the interior heat on Mars that made that happen. And so it simply gets cooler at the places where the rocks were erupting, and the rocks have solidified well down into the mantle of Mars. How about Earth, Marina?
So I'll use one of the places we visited on Earth, Hawaii, as an example. And this is sort of a unique example because Hawaii is an example of hotspot volcanism, which essentially is just a really, really hot plume of mantle that comes up in the middle of a tectonic plate and creates a volcano. But the tectonic plates on Earth move over time. And so that's how you've created this chain of Hawaiian islands stretching north up into the Pacific Ocean. And so once the plate moves off of the hotspot, the volcano that was formed becomes extinct. So that's why the other islands of Hawaii, like Maui, Oahu, etc., are extinct volcanoes because they no longer sit above the hotspot that made them volcanoes in the first place.
And that hotspot is now underneath
Kilauea, which is why it's active.
The big island where many of us astronomers go all the time and use a telescope on Mauna Kea, which is dormant. Hopefully it stays dormant, as there are some of the best telescopes there. I think that's all the time we have. You guys, thank you so much for such a great program. For those in the chat right now, we're going to drop, I think we've already dropped it, a link for a survey that we'd love if you could fill out so you can give us feedback on what you like, what you'd like to see more of, what changes you might want to see. Your feedback's really important to us. So please do fill that out. And if you do, everyone who fills one out gets a NASA sticker in the mail. I certainly have NASA stickers all over my laptops, so I feel like you want this. It's pretty cool. And two last things. We do have one more Astronomy Live program left. It's going to be on the first Friday, June 4th at 1 p.m. It's going to be myself and Marina back, and maybe even one other special guest, we'll see, to explain to you the annular solar eclipse that's headed your way, depending on where you are on the planet, because I saw people from India in here, I saw people from different parts of the world, so it's not necessarily going to be visible for everybody, but for those, we'll explain who's going to get to see it, and we'll be using OpenSpace again. So reminder also, Denton mentioned that on Wednesday, May 19th at 7 p.m., we have a Frontiers lecture, more on volcanoes. It's going to be called Volcanic Worlds. Marina is going to be flying OpenSpace for it, and you'll get to see a closer look into volcanoes on Venus, Mercury, and Mars. And there'll be a link in the chat here for you to get your tickets. I think that's it from me. Just a reminder, everybody, to come visit AMNH, right, Denton, Marina?
Yes, and come see the space show, Worlds Beyond Earth.
Yes, and the new Hall of Gems and Minerals on June 12th.
New Hall of Gems and Minerals and new content in the Hall of Meteorites, the Arthur Ross Hall of Meteorites. And thank you, everyone, for attending this presentation. It was really fun to have such great questions and to be able to show you a little bit of the solar system using our OpenSpace tool.
Thanks, everybody.
Thanks, everybody. Bye-bye.
Bye-bye.